So now whatever expression we got before, which is probability of S is equal to Tn approximately equal to 1 over A root n times b to the n, where A is equal to root 2 pi times 1 minus t, I think that was it, times t, this t outside, right? Yeah, that's what it was. B is equal to 1 over 2 times 1 minus t whole to the 1 minus t times 1 over 2 times t to the t, right? So we're trying to plot these expressions and see how they look. Alright, actually I do want to apologize that I think I made a mistake in the previous question when I forgot to put a t in the final answer. I think I missed in one of the steps, but I'm sure you guys would have figured it out on the way. Okay, so why does this plot look like this? So we have for this is for n is equal to 10, this is for n is equal to 20, this is for n is equal to 100. So why does this plot look like this? As in, why is it steeper for a larger n? So it's just intuitively, if you have a large amount of coin tosses, the probability of getting a very small fraction is going to be, even though the fraction stays the same, but you have an exponent of a larger n on top. So this expression on the inside is going to go much smaller, because you have the same expression on the inside, and between 0 and 1 this expression is going to be between 0 and 1 the whole time. The smaller your expression is in terms of probability, in terms of the exponent, and you have only a constant factor on the inside, b remains the same. And since you have a larger exponent on top, and this thing is just going to be a number between 0 and 1, if you have a larger exponent, it dies down, it jumps down much faster. So the larger the exponent, the faster it goes down. That's why it's steep for as n increases. And yeah, so for the smallest of n, you don't have that much of a difference between the probability of the different sample points. But as n goes to 100, you have a number which is less than 1, which you are taking it to the 100th power, right, to the exponent of 100, and therefore it actually has a much steeper graph because it rises and falls much faster. Now let's look at the plot for part 2, for question 5. All right, so this is the plot for part 5. This is t is equal to 1 over 2, t is equal to 1 over 3, t is equal to, put arrows, t is equal to 1 over 4. So this makes sense that the one on top is going to be the t is equal to 1 over 2, because as you get larger and larger n, the fraction of heads. So what does t equal to 1 over 2 say? It means that it's the probability of getting a fraction of exactly half for heads, right? And as you have a larger and larger number, you would expect the fraction to go closer and closer to half. And things like t is equal to 1 over 4, because you're throwing unbiased coins, t is equal to 1 over 4, having a fraction of 1/4 to be heads is going to be much smaller as n grows larger and larger. So we see that the curve for t is equal to 1 over 4 goes down very sharply, but the curve for t is equal to 1 over 3 goes down a little less gradually, little less sharply, more gradual, but it's still not the same as t is equal to 1 over 2. T is equal to 1 over 2 dies down very slowly, because the probability of getting a half, even though it goes down a little bit, it goes down. The probability of getting half the number of heads and tails is still going to be the most, what you would expect to see the most as n increases, right? So that's why this plot makes sense. And that's why t is equal to half is going to be above t is equal to 1 over 3 and t is equal to 1 over 4. That's it for question 13. Question 5 of homework 13.